Welcome to Hack to Secure Information Security Concepts and Secure Design Principles course. In current video, we will learn basic concepts related with TLS and SSL protocol and see how its handshake process make use of PKI for key distribution. Transport Layer Security or TLS and its predecessor, Secure Socket Layer or SSL, are set of transport layer protocols which uses public key infrastructure to provide flexible encryption scheme. This set of protocols uses X509 certificates and asymmetric cryptography to authenticate counterparts with whom they are communicating and for key exchange between them. After effective key exchange, a common set of keys are generated at both the ends and thus further make use of symmetric cryptography for channel encryption. Due to use of X509 certificates, certificate authorities and public key infrastructure, it validates identity of a subject or certificate owner. Along with this, protocol maintains a stateful connection by using a handshake procedure and proper message integrity check. This prevents communication from sniffing and tampering. So, overall, TLS and SSL protocols ensures confidentiality, integrity, and authenticity of keys. However, it can't ensure security services like non-repudiation, as neither proof of origin nor proof of delivery is ensured. We should note that TLS and SSL protocol provides security benefits to data during transmission. It does not offer any security benefit to data at rest. So, appropriate security controls must be added to protect data while at rest within an application or at data stores. TLS and SSL are socket-oriented protocols. Thus, encrypts a socket or transmission channel between sender and receiver, but not data. This is the main reason which makes these two protocols independent of application layer, and so any application or even a higher level protocols can be protected using TLS and SSL protocols. For example, TLS and SSL, when used with HTTP protocol, results in safe and secure HTTPS protocol, which is commonly used nowadays for secure and encrypted web transmission. Let's examine TLS and SSL protocol handshake process. Here, we will see how client and server public and private keys along with different attributes are used to calculate a symmetric key and is further used for encrypted communication. In TLS and SSL handshake process, it is not always necessary that both server and client have separate key pairs with them. Here, client may or may not be having a key pair. Actually, it all depends on server configuration and PKI implementation. In handshake process, client's public key is only used to ensure client's identity. If an organization's security policy, like in most cases, allows server to make connection with any user without validating its identity, requirement of client certificates can be skipped. Let's consider a user Tom. He wants to access his online bank account using a web browser. In this scenario, bank web server will act as a server with a set of public and private keys, while a web browser which uses Tom's public and private keys will act as a client on behalf of user Tom. To initiate handshake process, client generates a 32-byte random number and sends it using client hello message to server. Since client machine is requesting for a secure communication session, message also contains a set of options that client is willing to use in order to communicate with server, like client's complete list of supported cipher suites, protocol version, and compression methods. On receiving client hello, server also generates a random number based on date and timestamp and reply to client with its hello packet called as server hello. Here, server makes choices based on client hello message, like cipher suite chosen from list of ciphers sent in client hello session ID, protocol version, and compression method. So, at the end of hello packets from both the ends, Random numbers generated at both sides are exchanged, along with attributes required for further secure communications. A cybersuit is a combination of different algorithms used to negotiate security settings for TLS and SSL protocol. Now, after server hello, server sends his public key or a certificate and may request client's public key or certificate. As discussed earlier, requirement of a client public key is optional. This step can be skipped based on server configuration. At client end, on receiving server certificate, client checks it for required server name, validation date, etc. fields to ensure server identity. At the end of this phase, client has random numbers generated at both ends and server public key. Server, on the other hand, also has both the random numbers and is pre-existing public certificate. As discussed earlier, this is an optional step to ensure client identity and signature. After validating server certificate, client sends his public key or certificate to server. Just like client, server also validates client certificate for required fields. SSL TLS protocol do not maintain track of proof of origin, means anyone can communicate with server. Moreover, till now everything is transmitted in clear text and is vulnerable to sniffing or tampering during transmission. To maintain integrity of a connection, client also sends his digital signature to server. Here, client encrypts his certificate or proof of identity with his private key and sends it to server. Server, on receiving the same, decrypts data with client's public key and validates received client certificate. Since private key is only maintained as secret at client's end, so encrypted certificate in this step ensures identity of client along with integrity in connection. Now, once negotiation terms are decided and identity of both sides are verified, client generates one more random number called as pre-master secret or PMS. This pre-master secret is encrypted with public key of a server and is sent to server side. Since pre-master secret is encrypted with server public key, server can only decrypt it using his secret private key to obtain original pre-master secret generated at client side. At the end of the communication, both client and server side have same ingredients with random numbers, pre-master secret, and server public certificate. All these are put into an algorithm and using negotiated attributes, both sides generate same master secret. This master secret will act as a symmetric key and will be used as encryption key in further communication. However, before moving ahead, both sides need to ensure if same master secret is generated at either end. To confirm generation of same master secret at the other end, client sends some data encrypted with master secret generated at his end. Along with that, it also sends end SSL handshake packet. If server has also generated same master key or encryption key, he will be able to decrypt received data with master secret generated at his end. To reconfirm and for the sake of integrity of connection, server again re-encrypts received data using his master secret and sends it back to the client. Along with this, server also sends an SSL handshake packet. Client on the other end decrypts received data from server using its master secret and validates it. Once the master secret is confirmed at both ends, further communication is done using master secret as symmetric key.